Biomechanics in implant dentistry. Tooth loss is a feature of mankind's existence, and success of a prosthesis depends on ability of the material to withstand loads, transmission of these loads. Let us move on to few terminologies related to biomechanics. Biomechanics is the application of principles of engineering design as implemented in living organisms. Dental biomechanics is the relationship between the biological behavior of oral structures and the physical influence of a dental restoration. And implants, on the other hand, is a two-element of tooth replacement with a material for replacement and an attachment mechanism. A search for an analog for the periodontal ligament gave a major breakthrough during the year 1950s and 60s. The loads that are applied are mainly referred to as the occlusal loads. The loads vary in magnitude, frequency, direction depending on the parafunctional habits. Low horizontal loads by perioral forces of tongue and circumoral musculatures. Vector is the process that involves both magnitude and direction. Vector resolution is the process by which three-dimensional forces are broken down into their component parts. Types of forces. Compressive. Maintains integrity of the interface. Tensile or shear disrupts or distracts the interface. The stress is the manner in which a force is distributed over a surface is referred to as mechanical stress. Magnitude of stress is dependent on two variables, the forces applied, cross-sectional area. A strain is a load applied to a dental implant may induce deformation of both the implant and the surrounding structures. Biologic tissues respond with the initiation of remodeling activity. The stress-strain relationship is referred to as the modulus of elasticity of the implant, resembles that of contiguous biological tissues, the less the likelihood of relative motion at the junction. Higher the impact load, greater is the risk of the implant and the bridge to failure, and more loss of bone to occur around the implants. The movement of force is defined as the vector, the magnitude of which equals the product of force magnitude multiplied by perpendicular distance from the point of interest to the line of action of the force. A total of 6 movements may develop about 3 clinical axes which induce micro-rotations and crystal bone loss. The clinical moment arms in implant dentistry are with reference to occlusal height, cantilever length and occlusal width. Occlusal height moment arm is directed along buccolingual axis, working or balancing occlusal contacts, tongue thrust or in passive loading by cheek and oral musculature. Cantilever length moment arm is the distance from the distal of the posterior implant to the center of the most anterior implant, which is called as the AP distance. Greater the AP distance, smaller is the load on the implant from the cantilever forces. Clinical experience suggests that distal cantilever should not extend 2.5 times the AP distance under optimal conditions. Square arch form offer smaller cantilevers and tapered arch form offer longer cantilevers. Occlusal width moment arm. Wide occlusal tables increase the moment arm for any offset occlusal loads. Buccolingual tipping can be significantly declined by narrowing the occlusal tables. Hence, there is more crystal bone loss when there is an increase in occlusal height and increased rocking of the prosthesis leading to further bone loss. Fatigue failure is characterized by dynamic cyclic loading conditions. Factors that influence fatigue failure are the biomaterial, geometry of implant, the magnitude of the force and the number of cycles it is subjected to. Biomaterials. The stress level below which an implant biomaterial can be loaded indefinitely is referred to as endurance limit. The titanium alloy exhibits a higher endurance limit than commercially pure titanium. Geometry influences the degree to which it resists bending forces. Even small changes in thickness can result in huge difference. The magnitude of load on dental implants is reduced by careful consideration of arch position, elimination of moment loads, increase in surface area possible to resist these loads. The biomechanical response. The mechanical properties of trabecular and cortical bore vary as a function of load direction, rate and duration. The mechanical strain exhibited in the bone is